All right, welcome to Properties of Quadratic Functions, Part 1. So I'm going to start off by explaining what the basic form of a quadratic function is. So it's a function, if we draw it out here, it looks kind of like this. So it's a function that has some sort of an x squared term. And it's really important that you always have something times x squared or maybe just x squared. This is really important. You've got to have this in your quadratic function. So this is a must have. Okay. Now there's other bits and pieces that you could have, like we could tack on some number times x, and we could tack on some sort of a number. Could be a negative number, but we could tack it on. So this is all the possible ingredients of a quadratic function, but you got to have this one here. You got to have the x squared to qualify as a quadratic function. Now, just pull the graph down a little bit. I'm going to tell you what the graph would look like. Okay, if you graph a quadratic function, you're going to get a graph that looks something like this. Okay, it's kind of a U shape that forever widens, and it can also be flipped over. Okay, sometimes the graph gets flipped like this, and this is described as opening down, whereas this one opens up. Certain key points on the graph, you have this little guy right here, which is our lowest point, or if it opens down, you have this little guy here. This is your maximum here, and here it's a minimum, and that point, surprise, surprise, is called the vertex. Okay, so that's the vertex, and you'll notice the graph seems to be symmetrical. And so if we put a line down through here, okay, that is our axis of symmetry. And it's kind of like a mirror. It kind of causes the graph to have two equal halves that are symmetrical. So axis of symmetry. So those are kind of the key ingredients of the graph. What I'm going to do now is I'm going to show you what your basic quadratic equation looks like. Your basic quadratic equation, I'm just going to write it over here. It is y equals x squared. Okay, so what I'm going to do is get a bunch of points in a table of values. Okay, so let's see if we can set up a nice big table here. I'm going to get quite a few points here. I'm going to get maybe x is -2, -1, 0, 1, and 2. When I square these x values, when I plug them in, this one becomes +4, this one's +1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So now what I'm going to do is I'm going to plot that on a grid. So I tried to get a grid ready to go. Oh, there it is. So let's just see if I can move this grid over just a little bit here. Okay, and what I'm now going to do is we are going to plot the points and have a little look at the graph. Okay, so our first point is -2 and then up 4, so right about there. And then we have another point at -1, +1. Then we have a point at 0, 0, and then 1, 1. And now that you can sort of see the graph taking shape, and then 2 and up 4. Now I'm going to attempt to draw this with a steady hand, try to get that parabolic shape. Maybe I'll start over here. Okay, something like this. Okay, and of course that goes up forever. Let's see if I can get this one to look pretty good. All right, didn't quite go through that point as neatly as I wanted, but you get the idea. That's our basic graph. And we've got certain key features, which maybe I'll write down over here. If we had to identify the vertex, we can see, aha, there it is at 0, 0. Don't know why, okay, let's see if I can clean that up. It didn't look very neat there. It got smudged on me there. Try that again. Vertex is at 0, 0. Okay, axis of symmetry. So axis of symmetry. Now that would be the y-axis, but the actual proper equation for that is x equals 0. So that's the axis of symmetry, and maybe we'll mention the domain and what that is, and the range. So we'll have a little look at our graph. Now the domain, remember that a parabola widens forever. So there's going to be graph all the way forever on the left and forever on the right. So I think it's all numbers that are the domain, all x's. And for the range, it looks like it's limited from basically positive numbers from 0 upwards. So we're going to say y is greater than or equal to 0. Okay, so that is the characteristics of that particular graph. Okay, so what I'm now going to do, one more example, and again we're just using a table of values. So let's see if I can paste in another grid here. Okay, so there it is, and again maybe I'll move it over a little bit more central. And now I'm going to give you the function that we want to graph now. So the second example here we want to graph is y equals 2x squared minus 4x. See if we can get a decent looking graph. So what I'm going to try and do is fill in a table of values best I can and use those points to create the graph. Knowing it's going to be a parabola helps. So let's put in a few good points. This time I'm going to start with 0. And then I'm going to move my way to the right. Okay. So if we plug in 0, well, we got 2 times 0 squared minus 4 times 0. So that's just 0. If we put in 1, we're going to get 2 times the 1 squared minus 4 times 1. So we get negative 2. And if we plug in the 2 and you work it through here, 2 times 2 squared minus 4 times 2, we're actually going to get 0 again. And if you plug in the 3, and I'll let you calculate it, we get 6. So what does the graph look like? Well, we have 0, 0. We have 1, negative 2. Then we have 2, 0. And then we have 3 up 6. So 2, 4, 6. Quite a ways up there. So I think I can see what's going on here. I think this is my typical parabola shape down here. And see if I can stretch this all the way up there without it looking good. Okay, that looks pretty good. And of course it's symmetrical, so we're going to have this side over here roaring up as well. And you can see here's the vertex, and it's at 1 and negative 2. Okay, so we got that. We can see where the axis of symmetry is. It's this line here going through an x-coordinate of 1. So for the axis of symmetry, just write that down here, is x equals 1. And maybe I'll just squeeze in the domain and range over here. The domain is all numbers. And the range looks like we're starting down at negative 2 and just getting bigger. So y greater than or equal to negative 2. Now there are some other points that are actually very important. And I'm just going to mention them here. We have the x-intercepts. Okay, and the x-intercepts here are this point at 2 and this point at 0. So we actually have 0 and 2 as x-intercepts. And coincidentally, at 0 here, we also have a y-intercept. That isn't always the case that it's the same, but in this particular graph, it is also an x-intercept. So just a kind of coincidence. So that's where I'm going to stop for today, and that's a pretty good start in quadratic functions.